So first, going towards our first we will recapitulate what we have seen in the week 3. So in week 3, week 4 we have seen the angular measurement. Okay. So different equipments used for measurement of angles in metrology are: the first one is the protractor. Okay. In that also we have seen two types. That is the simple one, simple protractor. Second one is the bevel protractor. Okay. In this also bevel protractor there are two types. One is universal bevel protractor. Second one is the optical protractor. Next we have seen the angle gauges. Okay. So in this addition or subtraction of angle gauge is possible. The third one is the sine bar. We have seen sine bar and sine center. So we can to use sine bar for angle measurement, we also need slip gauges. Okay. Similarly, the fourth instrument that we have seen is spirit level. So the modified version of spirit level for larger angle measurement is clinometer. Okay, it is the combination of protractor and spirit level. Similarly, some optical angle measurement techniques we have seen. First one is our autocollimeter. Okay. Okay. In that also we have seen the digital and visual. Similarly, the small variation in autocollimeter, that is the auto-decker. So these are the basically the 6 types of angle measuring instrument that we use for angular measurement. So with this we'll proceed towards the problem. The first question is, which of the following instrument is used to align the structural members? Can anyone answer this? Mr. Hansraj, Mr. Ramlal. Anyone? Mr. Hansraj?
Sir, spirit level.
Okay. So let's the correct answer to this question is spirit level. Okay. So why is it so? If we take a combination set, okay, if we take a combination set, so you can see that. So in combination set, we can mark the center of a circle, or we can measure the angle using the graduated protractor, or also we can measure the height or depth of a part using a square head. So we can't use combination set to align the structural members. Similarly, with the vernier, we can measure the diameter, or we can simply measure the length, okay, of the part. Okay, so this means we can't use vernier caliper for the alignment. Okay, so if we consider a spirit level, so this is our bubble, and we will be having a spirit inside it. So if there is any small deviation like this, so we can use a spirit level, and according to the position of the bubble in the spirit level, we can align our member. So the correct answer is spirit level. So moving towards our next question, that is, which of the following instrument is or considered most precise in optical tooling? Can anyone answer this? Mr. Hansraj, Mr. Ramlal?
Sir, option D.
That is both collimators and angle takers.
Yes, sir.
So first thing, yeah, Mr. Hansraj Sharma, you are correct. The correct answer is both collimators and angle takers. So in this question, they have asked the most precise optical tooling. Okay, so we can eliminate one option, that is electronic clinometer. Okay, it is not optical instrument. Okay, it's based on the principle of spirit level. Okay, and protection. Hello. Yeah, Mr. Roderick. You want to say?
Yeah, sorry. No. I want to say. I wanted to give that answer also.
Okay.
Sorry.
So we can eliminate one option, that is the electronic clinometer. Now we have the collimators and angle takers. Okay. The collimators means our auto collimeter. Okay, auto collimeter and angle taker. And this works on the principle of light. Okay, light reflection of a light. Okay, so these are very sensitive, a very sensitive instrument. So even if the small variation in the flatness that we can detect using this instrument. Okay, so these are the most precise instrument that we can use for checking the angles or flatness of a surface. So correct answer is this one. So any doubt? Okay.
Clear, sir.
Yeah, Hansraj. Hello.
Yes, sir. Clear, sir. All clear.
Okay. So moving to our next question, that is the difference between one vernier division and two main scale division in a universal bevel protector is 1 degree, 1.5 degree, 5 minutes, 5 seconds. Yeah, Mr. Rodri.
Sir, 5 minutes.
Okay. Any other answer? Okay. Yeah, you're right. You're right, Mr. Hansraj. The correct answer is 5 minutes. Let's see why is it so. So if you can see the scale here, so this one is our main scale, and this one is our vernier scale. Okay, so one main scale division is equal to 1 degree. So as we can see from this image, okay, and if you count the division from 0 to 60 on both the sides, it comes out to be 24 vernier scale division, and that is equivalent to 46 of main scale division. So if we calculate one vernier scale division, it comes out to be 1 of 23 degree. Okay. So when our 5 minutes on vernier scale moves towards the 60th 60th minute, the main scale will show the reading of 2 degree. So main scale will show the reading of 2 degree. So 2 degree when 5th minute moves towards the 6th minute. So it means the least count or the minimum reading that we can measure will be 2 main scale division minus 1 vernier scale division. So if we calculate 2 minus 1 by 12 into 23, it comes out to be 1 of 12th degree, or simply if we convert it into the minute, it comes out to be 5 minutes. So the correct answer to this question is 5 minutes. Any doubt in this one? Okay. So let's move towards our next question. To eliminate confusion while reading vernier scale, one should always read the vernier from 0 in the direction of the main scale. This statement is true or false? Anyone?
No, sir.
Yeah. Any other answer?
Me, I think it's true.
Okay. Yeah. And why is it so? Yeah, you're right. The correct.
To align the reference with the reference of the angle.
Yeah. So let's consider I have incorporated the image of simple vernier scale. So we can use a bevel protector and the vernier scale from it also. So here you can see, if we read from this direction, okay, that is opposite to the 0 direction. So we might get confused where these lines interact, okay, and sometimes we can measure these lines from this side, okay, like from opposite direction. So it can produce error, like our main scale reading will be, measured reading will be main scale reading plus vernier scale reading. So we can get error in this vernier scale reading, and which will reflect the error in our measured reading. So it is always preferable to read the vernier scale from the 0 in the direction of a main scale. Okay. So next question is, sine bar becomes inaccurate with the increasing angle. Can anyone answer this? Anyone?
Me, I think it's true.
It's
When the angle becomes bullish, I think it's true.
And why is it so? Okay. So let's see. Suppose. Okay.
Yes, true.
Yes. And why is it so, Ansraj?
Difficult with the sign bar,
Yeah.
the handling and positioning of the sign bar.
Okay, that's one of the reason, but the main reason is in its mathematical formula. Okay, let's see.
Yes.
Okay, so this is my surface plate. Let's see. Okay, this is my sine bar. These are the slip gauges. Okay. Okay. So this height is H, and the length of a sine bar, that is distance between the two rollers, is L. Okay. If I calculate the sine of this one, the sine theta, that is this angle. Okay. Okay. The sine theta will comes out to be the opposite side of a hypotenuse, that is
H by L.
H by L. Okay. Okay, so sine theta is H by L. Okay, if I want to check the variation in the theta with respect to the H, so I will differentiate H with respect to theta. So this comes out to be cos theta into is equal to 1 by L dH by d theta. So if I want to calculate d theta, that is the variation in the angle, comes out to be dH upon L 1 upon cos theta, and d theta is equal to dH upon L. Sorry. So d theta by dH is nothing but sec theta upon L. So the sec theta is increases with increase in the theta. Okay. So if it means that if the theta is increasing here, so it is resulting in the increase in the sec theta, and that in turn resulting in the increase in the error or deviation of the angle that we are measuring. So what does it indicate? That the increase in theta reduces the accuracy, or it gives the inaccurate result. So suppose let's consider like if our L is 125 mm and theta is 10 degree. Okay, and the change in length, or that one delta 1 L is equal to 1.25 micrometer. So if you calculate for theta equal to 10 degree, it comes out to be 0.36 seconds. Similarly, if you put value, like if you increase the theta, it comes out to be 0.72 second for 20 degree. Similarly, for 45 degree, it comes out to be 1.7 seconds. So if you keep on increasing the angle beyond 45 degree, the error gets multiplied, or it gets increased.
Exponential increase in error. Am I right, sir? Exponential increase in error.
Yeah, somewhat like that. But it's not like exponential. Like we need to calculate for each and every theta value. Then only we can say whether it is the exponential or not.
Yeah, exactly, sir.
So that's why the sine bar becomes inaccurate with the increase in angle. So the correct answer is true. So moving to the next question. Any doubt in this?
Sir, excuse me, sir. Here, I don't have doubt in this particular question, but in this figure, I wanted to raise one more doubt, sir. Can I raise it, sir, on sign bar?
Yeah.
See, there are two fixed rollers. That is, L is fixed as far as individual sign bar device is concerned.
Yeah.
But somebody was telling we have the instruments which is adjustable length. The rollers distance between two or can be changed.
No.
Can be
We have
altered.
a
You think
different
so?
set of sign bars.
Correct. But within the same device, within one device, it should be fixed. Am I right, sir?
Yeah. For the same device, the length will be fixed. We can't change the position of the roller.
Yeah. Okay, sir. Thank you. Please proceed, sir. Thank you very much.
So moving to our next question. Two narrow ends lying opposite to each other in the angle gauge provides the addition of angle or subtraction of angle or multiplication of angle or none of these. Can anyone? Okay. Anyone? It's just a simple question, okay? You just know that whether we can add, subtract or multiply in angle gauges.
Sir, I think so. Might be subtraction. I think.
Yeah, Mr. Hansraj, you are right. The correct answer is subtraction. Okay. So suppose if I have one angle gauge, okay, and this is the narrower edge and this is the broader one, okay, and if these two edges are opposite, okay, like this is 30 degree, I can say, and this is 5 degree. So in these angle gauges we can subtract the angles, but in slip gauges it is not possible. We can always add the slip gauges. We can't subtract from the slip gauges, but in angle gauges the subtraction is possible. So the subtraction is possible. Similarly, the addition is also possible, but in question they have asked about the two narrow ends lying opposite. So if the narrow ends are opposite to each other, then only subtraction will happen. If the two narrow ends are in the same side or the same direction, then the addition will happen. If narrow ends lies opposite, it's subtraction. Narrow ends lie in same direction, in same side, then it's addition. Okay, this is just a simple question. So moving to our next question, that is, the angle gauges are more accurate than sine gauges as the latter involves trigonometric formula. Is it true or false?
It is true, sir. True.
Yes, sir. Yes, Mr. Prabhakaranji, you are right. It's true.
Yes, sir.
Because the
Sign bar.
Yeah, because of the sine bar also, as
Calculation.
we can see in sine theta, h by L. Okay.
Yeah.
So it depends on the trigonometric formula, means how many digits that we consider, or
that is
mathematics. That's why it gives the error.
Yes, sir.
Error in our So this is just a simple question.
Yes, sir. Thank you.
Yeah. Moving to our next question, that is, clinometers are used for. Okay, sorry, my screen is not visible. Now is it visible?
It's visible, very much visible.
Yeah. The clinometers are used for blank space angles. Larger angles, smaller angles, medium angles, or none of these. Can anyone?
Sir, might be none of these.
Any other answer? Okay, so Mr. Hansraj, you are a bit wrong. Okay, the clinometers that we use for measurement of the larger angles. Okay, so it is the
Okay.
advancement of our spirit level. Okay, so its clinometer is nothing but the advancement of our
Spirit level.
spirit level. Yeah, using spirit level, we can measure very small angles. Okay, not much that much like not larger angles we can't make measure using the spirit level. Okay, so the our clinometer. Okay, so clinometer is combination of we have seen in the very beginning, that is the protractor plus spirit level. So let me draw the clinometer for you. Okay, this is a slide wheel. This is a scale. Suppose here I am having a clinometer or the stylus, and in this one we will be having a spirit level. Okay, and this is the base or data. So suppose this is my workpiece and I want to measure its angle. Okay, this angle, like how much the inclination means, how much inclination is there. So what I will do, first I will measure the angle. First I will make my stylus parallel, and I will rest this one on the inclined face. Okay, so suppose this is my inclined face. So what I will do, first I will keep my stylus parallel to that one. I will bring and then I will make the contact with that inclined face, and I will mark the angle on scale. Suppose this is the reading R1. Okay, and similarly what I will do, then I will make this hand or stylus at the top edge. Okay, I will keep it at the top edge so that the bubble in the spirit level should be horizontal. So suppose this is the, and the bubble is horizontal in this one. Okay, so horizontal position. So I will check, and this is the reading R2. So using this one, we can get the theta to be R2 minus R1. Okay. So have you understood, or should I explain?
Yes, sir. Yes, sir. Very systematic. Correct.
Yes. Okay.
Yes, sir. Like also clinometer is used for the to check like for the flatness of the surface.
Yeah.
If we have to check flatness.
Yeah, we can use, but it will not be that much accurate. Okay.
Okay.
Yeah.
So what about smaller angles?
Yeah, smaller angles also we can measure using the clinometer. Okay. So generally for smaller angle, 2 to 4 degree, we prefer the spirit level.
Spirit level.
Yeah, and but for the larger angles, if it is 30 degree, 40 degree, and you want to measure its angle, means roughly, means not that much accurate. Okay, up to a single point, you want to measure the angle, then you can go with the clinometer.
Clinometer.
Yeah, if you want a very high accuracy, you can go with the angle gauges, or either you can go with the autocollimeter.
Yes, sir. Yes, clear, sir. Thank you.
Moving to our next question. Which of the following instruments can be preferred to verify the angle standards? Anyone?
Me, I think that is digital autocollimator
Okay.
can be used.
Okay. And why? Is it,
Digital collimeter, sir. Digital auto collimeter.
and why is it so, sir? Can anyone?
This is the reference, like master, we can use it, and this is more accurate also
Yeah.
comparing to the other slip gauges, and direct reading also we are getting more accurate also.
Okay. So the correct answer one is digital autocollimeter. Okay, because slip gauges are linear measuring instrument. Okay. So here we have asked about the verify the angle standards. Okay. So slip gauges can't be the answer. So if we come to the clinometer, so we can measure the angles. Okay, but the accuracy is low. And if we want to measure the angle standards, then we need a very high accuracy. So in autocollimeter, it's very sensitive instrument. Okay, and works on the reflection of a light. So even the small tilt or the small deviation in the angle, that also we can detect using the autocollimeter. So it will be better to use the digital autocollimeter to verify the angle standards. Okay. So similarly, we can use the angle decker also. Okay, as angle decker also act as a comparator to verify the standard. So we can either use the digital autocollimeter or we can use the angle decker. Yeah, but if the two options are given, like a digital autocollimeter
Is the better one.
or autocollimeter or visual autocollimeter. So if we consider, both are the accurate one, okay, but the most accurate one will be the digital autocollimeter. As the visual autocollimeter will be involving it is based on the eye of a person that checking. Okay, so it can sometimes produce some error or some deviation. So
Human error.
Yeah, so
Human error also will.
Human error, yeah. So as it's involve human error, so it is better to go with the digital autocollimeter. Yeah. So any doubt, anyone?
Sir, actually, regarding this question, no doubt, but the application of this autocollimeter, can you use it, since it has got the very high resolution of accuracy and direct reading, we can use it for calibration purpose. Am I right, sir?
Yeah. We can
and slip gauges. Local, internally, within if we have in our workshop both digital autocollimeter and slip gauges, you can use as and when required, depends upon the requirement, slip gauges, and you can use this one digital autocollimeter exclusively for calibrating this angle measurement instrument.
Yeah. We can use that.
Yes, sir.
But we should be having we should have a standard set of for comparison, like how much the error is coming in that user one and the standard one. Okay.
Yes.
Yeah.
Master one and
master one. Yeah, we will be
correct, sir. Yes, sir.
Yeah, workshop grade or other tool room grade.
Thank you.
Yes, sir. Like, what about like autocollimator and angle deckers? Like, which will be more
Uh,
accurate or effective?
like more accurate one is if we see that both are the accurate one, okay, but works on the different principle. Like in angle taker is not the direct angular measuring equipment, okay, but it is the angular indirect angular measuring instrument, okay. So what will happen? We will in angle we can use the autocollimator directly, okay. We can detect the angle. But in angle decal, what we will do? We will take a standard set of angle gauge from market, yes, and then we will check it whether it is correct or not.
Okay, sir. Yes, sir.
Yeah,
So one more doubt, sir.
yeah.
So there is this precision for the precision measurement of angles of non-mirror quality surfaces. Which one will be better, sir? Visual or digital or laser or angle decor, sir?
So
Non-mirror quality
laser one will be the better. Okay, like it's
or non-quality, sir. Non-mirror quality surfaces. Rough
not that
surfaces.
much polished surface.
Yeah,
Yeah.
rough surfaces comparatively. So which one will be apt for
Uh,
precision measurement?
for precision measurement, okay, sir. Sir, I will look into this. Okay, next
Yeah.
time I will explain you. Okay, like because this all are the same one. Okay, like but the as in laser autocollimeter, we are using the monochromatic laser, and in order like in digital autocollimator, in a autocollimator we use a collimated beams. So there is a chance of some diversion in the beams of that autocollimator. There is a chance of diversion in the autocollimated beams as compared to the laser one, as per I know. Okay, but I
Okay.
will definitely look it.
Yeah, sir. Please. Appreciate for getting the answers. Thank you.
Yes.
Thank you.
So, next question. Can we measure a 24.5001 mm using M112 set of sine gauge? Anyone? Anyone? Can anyone answer? Can we measure 24.5001 mm using M112 set of sine gauge?
That is 0.1 micron accuracy, least count. Am I right, sir? 0.1 micron,
Yeah.
least count. I don't know the quality of M112 sine gauge.
Sir, the answer is hidden inside the question itself.
Can use? Yes, we can use.
Yes, sir. I think so. Yes.
Yes.
Okay. So the correct answer is no one. Okay. Why? Because M112, okay, is a set of slip gauge. Okay. And here they are asking about the sine gauge. So for slip gauge, we can call it as a Johansson gauge also,
Okay. Okay.
or also gauge block. Yeah. So, but they are asking about the sine gauge. There is no thing like a sine gauge. Okay, like we can use the sine bar with slip gauges. Okay. So here they are talking about the linear measuring devices. Okay. If they have written the slip gauges here, then definitely the answer is yes. But for this question, the correct answer is no. Okay.
Yeah, agreed. Thank you, sir.
Yeah. Moving to next question. Bevel protector is used for linear measurement, angular measurement, height measurement, flatness measurement.
Angular measurement, sir.
Any other answer? Okay. Yeah, you're right, Mr. Karanji. Yeah, Hansraj. Hansraj, would you like to say something?
Yes, sir. I am saying that angular measurement will be there.
Yeah.
Bevel protection.
Yeah. So the correct answer is the angular measurement. Okay. So for linear measurement, we use generally vernier, steel rule, screw gauge, or some like height gauge, etc. Okay. But for angular measurement, we use protractor. What are that 7 instruments that I have listed earlier in the beginning. So the angular measurement, we use the bevel protector. Okay. So like some can say that we can measure the flatness of the some people says that we can measure a flatness also. Okay. But that is wrong, because in bevel protector that steel rule is there. We are that will be acting as the frame of reference, or okay, that will be using that one only we can measure the angle. Okay, if we keep that suppose this is my steel rule, and if we keep on that surface, so it will measure
worn out and accuracy will be lost. Angle accuracy
will be worn out and accuracy will be lost. Okay, so we basically use bevel protector for angular measurement, but not for the flatness or.
But tendency of production person, they used to say just like that,
sir,
they
but
just touch us and you are right.
Yeah, if not that much accuracy is needed.
Rough measurement, but the accuracy of that bar will be lost.
Yeah.
Thank you. Yeah, thank you.
Yeah. So moving to our next question. Hello. Is it screen visible?
Sir, visible, sir.
Okay.
Now it is visible. Okay. The least count of a vernier bevel protractor
is 10 minutes, 5 seconds, 5 minutes, 10 seconds.
5 minutes, sir?
5 minutes.
5 minutes.
We already discussed this question. What is the difference between the 2 main scale division and 1 vernier scale division? Okay, that is nothing but our the 5 division. 5 minutes.
5 minutes.
Yeah. So moving to our next question. That is, this is also a similar question. Okay, means the language is somewhat different. Always read the vernier from blank space in the same direction that you read the dial scale.
Sir, from zero in the same direction.
Yeah, you are right, Mr. Hansraj. The correct answer is 0. We have already discussed the answer of this question. Okay, so I think there is not much explanation needed. So moving to our next question. The spirit level performance is governed by the geometrical relation between the bubble and a single datum, its top plate, 3 reference along mutually perpendicular direction, or 2 references.
Sir, bubble and its top plate, sir. Between bubble and its top plate.
Okay. Any other answer? Okay. Any other answer? Okay. So the correct answer is the 2 references. Okay, not its top plate. Why is it so? We will see. Okay. So suppose this is the glass of my spirit level, and here I am having a bubble. Okay.
Yeah.
So if that is at 0 degree, okay, so it means it's perfectly flat. So if we moved our spirit level somewhat, yes, you can see some markings, okay, on the spirit level. Like there's some markings will be there, like two black.
Yeah, it will be good.
If you have gone through the lab demonstration, you can see the two markings, okay. So within this marking, means the performance is depend on these two markings, okay. So if it moves away from these markings, okay, if it goes out from this marking, like if the bubble moves this side, okay, so it will be creating some angle theta, okay, after traveling some distance, yes, okay. So the performance is governed by the geometrical relationship, and it is governed between the bubble and these two lines.
Marking.
This is
End
the
markings.
two references, okay.
Correct.
So yeah,
Yes, agreed, sir.
yeah. So the datum that we use, it just for the reference, okay. Okay, but the performance is depend on the it's these two references.
Yes, sir.
Yeah.
Agreed, sir. Thank you.
Moving to next question. Which of the following statement is true about sign bar? The longer the sign bar, the better the accuracy. The shorter the sign bar, the better the accuracy. The accuracy of sign bar does not depend on an ambient temperature. A sign bar cannot measure unknown angles. Anyone?
Shorter the sign bar, the accuracy will be better. Second choice.
Any other answer? Yeah, Mr. Ram.
Maybe C, answer C.
Okay. So let's see the answer for this question. So, like in sine bar, the angle is sine theta is nothing but h by L. Okay, this is the height of slip gauge.
Yes, sir.
This is the length of sine bar. Okay,
Yes, sir.
sine bar. Okay. So on the partial differentiation, okay,
DH by DL.
differentiation, we get cos theta d theta equal to LDH minus SDL upon
Yes.
L square. Okay. So if I multiply to this first term, okay, this first term by h by h, okay, so I can get cos theta d theta is equal to h by L dh by h minus by L. Okay. So if that is the h by L, okay, that is d theta, okay, and if I do the calculation and I bring the cos theta term this side, so this d theta can be tan theta dh by h minus dl by l, okay, or otherwise in simple term the equation that we have written, d theta dh is equal to sec theta by l, okay. These are the two alternate variation, okay. These two are same, okay. There is no change, okay. So as you can see, the longer the sine bar, okay, that L is increasing. So, okay, if L increases, the d theta will decrease. Means the accuracy is higher. So, first statement is correct. Okay. So, similarly, if our L is decreasing, that is the length is decreasing, okay. If the length decreases, the d theta will increase. So, the shorter the sine bar, the better the accuracy. So, it is wrong. Okay, it is false. Okay, it is not true. Like with decrease in the length of sine bar, the accuracy decreases. Okay. So the third one is the accuracy of a sine bar does not depend on an ambient temperature. Okay. So sine bar will be made up from some material. Okay. And it will have some coefficient of thermal expansion. Okay, so if the ambient temperature changes, there can be a change in the length of the sine bar. Okay, and that will decrease. That will affect the accuracy of the sine bar. So this statement is also wrong. Okay, and a sine bar cannot measure the unknown angles. Okay, if it does not measure the unknown angles, then what is the meaning of okay.
Correct.
Yeah. So
Definitely outright
yeah,
wrong.
yeah, definitely this will be the wrong one. So
Yes,
the correct answer will be the only first one. The longer the
Length.
sine bar, the better the accuracy.
Accuracy.
Okay. So one more thing here, I forgot to mention earlier. So like that sec theta is there, na? Sec theta, it increases rapidly if the theta goes above 45 degree. Okay. Like if we see the curve, sec theta curve, so you can see that the sec theta value increases rapidly if the theta goes above 45 degree. So if sec theta is increasing, it means the d theta is also increasing. That is, it will give the less accurate result. So that's why we generally don't prefer sine bar for angle measurement above 45 degree. Okay, like it means there might be if the small deviation can occur, the larger changes in the means it will give the larger error. So that's why people prefer to use sine bar below 45 degree. Okay, there are some other methods like we can use inverted sine bar to measure the angles above 45 degree, like that. So that I think sir will discuss in the lecture. Okay.
Yes, sir.
Okay. So moving to the next question, what is the range of bevel protector? Okay, I think in lab session sir has shown the bevel protector. So from that also you can tell how much angle or what is the range of bevel protector.
Sir, from like 0 to I think so 180 degree, up to 180 degree, it can measure.
Me, I think you can measure from 0 to 30 to 360 degree, but divided in 4 parts.
Okay. So the correct answer is 0 to 360 degree. Okay. So if you have seen the bevel protector, that we can change the position of the scale and make that scale parallel to the inclined surface, and we can measure the angle. So if the angle is from 0 to 360 degree, any angle we can measure. So there is no limitation like between 0 to 90 or 0 to 180 that we can use. Okay, but if we talk about the simple protector, okay, that we use in our school, so it will be like a semicircle shape. Okay, so here we will be having the marking from 0 to 180 degree. So, but here they have asked about the bevel protector, not the simple protector. So using bevel protector, we can measure any angle between 0 to 360 degree. Okay. By the way, can anyone tell why we are considering the angle 360 degree as a complete circle? Why not 365? Why not 370? Like this circle is divided into 370 parts. Okay. Why not? Does anyone know? Like why we consider 0 to 360 degree as the angle of circle?
Sir, because we have 4 quadrants in a circle.
No.
Each quadrant 90 degree.
No. Mr. Prabhakaranji, do you know?
Yes, sir.
Yeah.
It's a tricky question, a very fundamental question.
Yeah.
As he said, we have 4 quadrants and a diameter, 2 diameters, so 2 halves only, half circle, 360 degree. Then it comes 361 is nothing but 1 degree, 2 degrees. It
Yeah.
starts
The
again.
answer is very simple. Okay. What happened in
Me?
olden days when the math was developing, some people have calculated how much time Earth takes to complete one rotation to the sun. Okay, so they calculated roughly during that time it's 360 degree. Means 360 days. Okay, 360 days. Okay, that was the rough calculation. Okay, so later they divided that if Earth is moving from this position and after 360 days it's coming back to this position. So that's why they are considering the angle 360 days as means previously in the older times, like in the 19th or 18th century, the calculation were not that much accurate. So they roughly took that the Earth takes 360 days to complete one rotation to the sun. That's why the angle 360 degree for the circle. That's just a simple question. I thought you should know. Yeah. Moving to our next question. In the first series of angle gauges, the gauges present are. So, which is the option? Correct option among. Anyone? Okay, so there are, if you see the standard angle gauge set, okay, there are 3 series. One is the first series, then second series, and third one is the third series. Okay,
139 2741, sir.
Yes, sir, you are right. You are absolutely right. Okay. So in first series, we talk about the degree angle. Okay, right? Degree, the gauges that measures the degree, and that are 1 degree, 3 degree, 9 degree, 27 degree, and 41 degree. Okay. In the second series, we talks about the minute. That is 1 minute, 3 minute, 9 minute, and 27 minute. And in the third, we talk about the second.
Seconds.
That is 3 second, 6 second, 18 second, and 30 second. Okay. So these are, if you count, it comes out to be 13. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. So this is the total 13 nodes of angle gauges that is used for measurement. That is the standard angle gauge set. Okay. So among this, if we check answer here, only this one matches with the answer. Okay. So that's why the correct answer is this one. That is the 1 degree, 3 degree, 9 degree, 27 degree, and 41 degree. Okay. So moving towards our next question. The clinometer is related to engineer's principle, engineer's parallel, angle gauges, spirit level, bevel protector.
Spirit level. Spirit level.
Yeah. Any other answer? Okay. We have already seen this question 2 times. Okay, that clinometer is the advancement of our spirit level, and it consists of protractor plus
Spirit level. Spirit level.
Yeah. So suppose in this question, if I add one more option like protractor and one more option like this is A, B, C, D, and E. So the correct answer will be C and E. That is the spirit level and protractor. That is, it is the combination of spirit level and protractor. So these things you have to consider. Okay, if the bevel, spirit level and protractor both are the given, then it means it is related to both of them. That is bevel, protractor, and spirit level. Yeah. Moving to our next question. The photoelectric micro optic autocollimator can be used as visual collimator. Yeah. Correct answer is the true one. Okay. Because in an autocollimator we have seen the two types, that is digital and visual. So we can use visual collimator, means photoelectric micro optic autocollimator we can also use as a visual collimator. Okay. So moving to our last question. So which of the following statement is true? An angle decker is a small variation of clinometer. Angle decker is a small variation of autocollimator. Angle decker is a small variation of a sine bar.
Option, sir. Autocollimator is the small variation of second
Yes.
angle.
Okay.
Decker.
Any other option? Would you like?
Me, I think an angle decker is a small variation of autocollimator.
Okay. Okay. So in all these three, the one common thing is the angle decker. Okay, as you can see, angle decker. So we should know the angle decker works on the principle of reflected light. Okay. So we can eliminate one option, that is the clinometer. Okay, it doesn't work on the reflected light, light, so it can't be the answer. Okay, one we have eliminated. The second decker, the angle decker is a small variation of autocollimator. Yeah, it's true. So this one is the correct answer. Okay, one. If you come to the third answer, an angle decker is a small variation of a sine bar. Okay.
No.
So angle decker works on the principle of light, reflected light. So how does the sine bar? So it can't be the answer.
Yes.
Then definitely none of this will not be the answer. So the correct answer will be the angle decker is a small variation of autocollimator.
Autocollimator.
Yeah. So we have discussed some similar question to that of your week 4 content. So if you have any doubt in these questions like that we have solved, so you can ask, or otherwise we can wind up your session here. So Mr. Prabhakaranji, I will look into it and next try to answer your question.
Sir, next class, next
Yes.
Tuesday.
Yes, sir.
Okay.
Thank you, sir.
Thank you. Good day to everyone.
Thank you.
Thank you,
Good
sir.
day.
Thank you.
Okay. Thank you for attending the class, and you can all can leave now. Okay.
Yeah.
Yeah.
Yes,